All right, so I realized after I made the video and posted it, I forgot to discuss about domain and range of these exponential functions. So I'm going to talk a little bit about domain and range in this video. So right here we have a parent function. This function is the function f of x equals 2 raised to the x. And I'm even going to put it in the calculator over here. F of x equals 2 raised to the x. And the domain of these functions are always going to be infinite numbers because I can plug anything I want into that domain, and there's graph on the left side of the axis and graph on the right side of the axis. And you can even check by looking at the table. So if I click create a table, we can put any kind of number we want. We can put negatives in. I can put negative 345 and it will give me a value. I can put positives. I can put positive 1,236. Ooh, I think that was a little bit too big, but we will always get a value. So on these functions, our domain is always going to be all real numbers. So when we write all real numbers for a domain, so I'm going to put D for domain, and when we write all real numbers in interval notation, we use a parenthesis, negative infinity, comma, positive infinity, close parenthesis. Now we use a parenthesis because numbers don't ever actually reach infinity. Infinity is not a number. Infinity is a concept of we get closer and closer and closer. We think we're getting to the highest number, but there's always going to be one more. So for that reason, since we don't actually reach infinity, we use parentheses. Now, when we're looking at the range, though, the range of these functions are very special because if you look at this graph, it only exists above our x-axis. There's nothing down here below our x-axis. If I were to flip this and put a negative 1 in the front, oops, I put two negatives, a negative 1 in the front, it would flip my graph upside down. So if I wanted it to be on the bottom of my graph, I would flip it upside down to make it under the x-axis. These functions are very unique and important because they have a very special concept that we learn about later in calculus. It looks like it's right on top of 0 here, but if I zoom it in, you can see that it actually doesn't touch the x-axis. It like runs parallel and gets very, very close to the x-axis. This idea is that it gets very close to 0, but it doesn't actually reach it. And that's what an asymptote is. So I talked earlier about there being an asymptote at the x-axis right here. This is our asymptote at y equals 0. So for our range, because we have that asymptote, we're going to say parenthesis 0, comma, and then because it's above our x-axis, it goes to positive infinity. Now, what if it was upside down? If it was upside down, it would be the reverse. You would have negative infinity and then 0 because it's in that negative area. So I'm going to do a couple more right here of this concept of domain and range for these functions. Here we have two of them. You can see they are shifted. This first one is f of x equals 2 to the x, and then we have a minus 2. This minus 2 is important because it tells me right here where that asymptote is. So that asymptote is at y equals negative 2. So our domain is going to be negative infinity to positive infinity, all real numbers. And then our range, since this time our asymptote is at negative 2, for our range, we're going to start at negative 2 and then continue on to positive infinity. Let's look at one more. This graph right here, you can see it's been shifted up 1, 2. So we have our asymptote right here at y equals positive 2. So again, domain, all real numbers, so domain, negative infinity to positive infinity. And then our range on this one, because our asymptote is at y equals 2, we put a parenthesis 2, and then to positive infinity. I hope this video helps a little bit with domain and range and that interval notation.